What's up guys, welcome back to the channel. My name is Lucas, and in this video we're going to go through some Google search techniques that are specific for machine learning. So one of the obvious things that you should know about, working with software or working with machine learning specifically is that you're going to do a lot of Google searches, right? Which is kind of obvious for everyone that works with development of any kind. And in this video, what I want to do is I want to go through some tips on how to do some advanced Google searches. Now, it's important to note that my inspiration for this video came from a really cool video by Fireship.io, and I'll show you which video it is in a sec. How to Google it like so.
Google to figure out how to do.
So the video that inspired me to talk about this topic is this video from the YouTube channel Fireship. That's called How to Google It Like a Senior Software Engineer. I'm going to leave a link on the description so that you can check this video out because the video is awesome, and I aspire to one day make as cool videos as this guy does. And what I decided to do is I did a little bit of studying of Google search. I've been trying to develop my own Google search skills so that I can be better at finding the stuff I need faster, right? Having said that, let's go through some of these techniques and some of these tips. Now, one of the first things that we do when we're working on machine learning is looking for machine learning papers. So one thing we could do is we could just write machine learning papers, right? The problem with this approach is you're gonna find a billion papers. You have to be able to filter your search so that you find the stuff you're looking for. Mainly in cases where you're not looking for anything specific, you just want to get a sense of a field, or you just want to get a sense. Sometimes you want to filter by date, filter by topic, filter by keyword, etc. So let's go through some techniques to do that. The first thing I want to talk about is using the cite operator. Now, with this operator, what we can do is we can say, I want to look for papers inside a given site. Right? Actually, not papers. I want to look for content inside of a given site. And in this case, obviously, we're going to look for papers inside archive.org, right? And what papers I want to look for? Well, let's look for machine learning, right? So that means that it will look inside the archive.org website, and we'll look for probably papers that reference some, in the abstract, reference the expression machine learning or topics related to machine learning, right? So having done that, the other thing that we can do is write down after column, and then we can say, well, let's say I want papers after 2020. And when I go to search, now I get responses that are only from archive.org and papers related to machine learning, obviously, where mostly they will either reference the word machine learning or they will be about the topic machine learning. And they're all, as we can see here, after 2020. So 2022, 2021, 2019. It says 2019 here, but when we actually go inside this paper, here it goes. It says May of 2021. So apparently we got results after the date that we specified, right? And if we wanted to be specific about a specific expression we want to look for inside archive.org, related to the papers we're looking for, we could put that inside quotes like artificial general intelligence, right? And then I want to say not after anymore. Now I want papers that mention the phrase artificial general intelligence, right? They have that expression, but they are between, let's say, 2019 and 2021. So I can write 2019 ... 2021 to have exactly that. So as you can see, I get a very small number of results compared to what you would get if you just research artificial general intelligence, for example. And when I actually go to these links, we're going to see that the expression artificial general intelligence is actually being mentioned somewhere inside that paper, content, etc. So you see, as you can see here. So let's do a test. We can say like, boom, found it. And then we can say, boom, found it. We can say, boom, found it. We can say boom, found the why, what, and how of artificial general intelligence. I mean, you get the gist, right? As we can see, the expression is being mentioned time and time again. And as you can see, you don't have to put stuff in capital case like this, because it will look for expressions lowercase and uppercase in the same way. So this is a little bit of the side operator and the after operator for stuff specific to looking for machine learning papers. But how about repositories, right? We're looking for code, and we don't want to go to github.com. We don't want to do this. We're not on github.com, and then we want to come here and then look for something. We want to do everything from Google search. So one thing we could do is, again, say site, right? And then we can say github.com. And then we can say some framework, for example, let's say PyTorch. And we also want to look for repositories related to recurrent neural networks. So let's say RNN, it has to mention RNN inside that website. And we want repositories after, let's say, 2020, and we want repositories after 2020, for example. So we can say after 2020. When we hit that, as you can see, we get github.com, and we get all these repositories related to RNNs, as we can see here and here and here. Let's check out some examples. If I were to look for PyTorch, and if I were to look for RNN, as you can see, we found this one, which is recurrent networks from scratch using PyTorch, which is actually a great example of what I'm talking about. GRU and LSTM, blah, blah, blah. So we found some issue solving. We found a list of searching for LSTMs. So if we say PyTorch here, found it in RNN, maybe this answer wasn't as great as we would expect, but it's fine. And also, again, RNN and PyTorch, right? And we can always filter out using more expressions and more keywords that we want to look for inside that topic. So, all right. So how about looking for tools, right, of a certain type? So, for example, I work a lot with computer vision, right? And a while back, I was trying to get a sense of like the best image annotation tools out there that I could use to facilitate labeling image data. So one thing I could do is just say image annotation tools. Well, I say image annotation tools, and I get all these answers, right? Interesting. So I see two answers here. Mainly this one seems like one of the best that I could possibly get, because they're like they're a list of image annotation tools. This one is also interesting. How could I make this search a little bit more specific and make sure that the topic and make sure that the tool is actually new, it's updated, and it's the best of the best? Well, one thing I could do is say image annotation tool, and then I could use the AND operator, which means that it will look for this expression and whatever other expression I'm about to write. In this case, I want to say open source, because I don't want to pay for the image annotation tool, for example, or whatever. And then I say after 2018, let's say, because I want the new stuff, or like the most updated list possible. And I don't have to say after 2020. I could say after 2020 if I wanted to. Why not? And when I look for that, then at first I get a few ads, but then boom, I get that list quicker. I get that other list of open source tools. I get the 13 best image annotation tools of 2021. So I get an updated list, a recent list of the image annotation tools. And I could, the cool thing about using the AND operator and then combining a general search for a topic with a keyword search is that as you are more specific about what you want, Google will actually feed you much better answers, right? When you know what you're looking for, it will always be better than if you just randomly Google some general topic. So this is an interesting one for looking for tools of a certain type. And then let's say you're building some data set, right? And you want to build, let's say, a pandas classifier, right? If an image is of a panda or if it's not a panda. So you're looking for pandas. What we could do is we could go and click in, we could go to Google, we can go to images.google.com, and we can come here and we can, get out of our general search, get out of the general Google search bar and go to the image search bar. And then here we go and we write, I'm looking for a panda. All right, cool. However, when we're working in machine learning, first we want to be fast, right? We don't want to search, we don't want to switch to the Google image search bar. The second thing is we want to have some specific conditions for the image we're looking for. So what we could do is we could come back here. So now I am in the general Google search bar, and I could say, well, image, right? And now I say panda. And I then use the image size, and I say 256 by 256. So now what's happening here is I am looking for an image of a panda, and I want that image to be 256 by 256. When I run this, let's see what is the output that I get. As we can see here, I mean, this is a weird looking panda, but there you go. You see, this is a panda. Maybe it's not exactly the panda that we would like, but it's a panda that if we check here, 256 by 256. And then another one, 256 by 256. And then we get this one. And as you can see, we got a bunch of images of pandas of all types and stuff. That have a specific size. But what about, I wanted, let's say image size of, I don't know, 300 by, I don't know how much in this size. So let's say use the wildcard symbol to say, I want an image size that has 300 by whatever. And when I run this, now I get a little bit of a more diverse set of answers because okay, cool. All right. Okay, cool. So now how about we talk a little bit about how to search for social media stuff. So let's head over to google.com, and let's say we're looking for some content on machine learning, and we want to look up some Twitter stuff like tweets or hashtags and stuff. But we could use the social media operator symbol for the Google search bar, which is the @ and then we can say Twitter. And now I could say a topic, let's say transformers. So transformers. And what I want is, since I want to look up this topic inside Twitter, let's say hashtag transformers. So now I'm looking for hashtags of transformers inside Twitter. And I also want the hashtag, let's say artificial intelligence, for example. So we're sure that we're looking for stuff that makes sense, right? So if we go like this, and then, let's see what we find. First, we're in Twitter. That's perfect. And let's see some of the results. So here it's a tweet from AI Mad, from this Twitter account. And, indeed, it mentions, artificial intelligence in medicine, NLP, boom, transformers. Very interesting that it wasn't the hashtag transformers, but it did mention transformers and artificial intelligence. And in this one, again, transformers. And then in this one, let's say, as we can see, transformers are referenced in this kind of like Twitter, the Twitter thread from Andrej Karpathy about consolidation in AI and that kind of topic. All right, cool. So that means that we can look up social media information and hashtags and content and topics right from our Google search bar, which is great because it's super helpful to use just one search bar to look up anywhere for anything. Another example that we can use for stuff that is related to machine learning that I think could be useful is, let's say you're setting up your new desktop for machine learning, right? And you want to look for GPUs. So you could go here and you can say GPU for machine learning, right? and then boom, you get a bunch of options and prices and stuff. But one thing that you could do is say, well, I want a GPU that costs up to 600 bucks. So we can use this operator, right, the dollar symbol, to specify that we're looking for GPUs that cost a certain amount. And when we look for this, there we go. So now we're seeing results that have that restriction in price and links related to GPUs, but as we can see here, under $600. So it's useful because if you're on a budget for it, it's useful because if you're in a budget, it's useful because if you're in a budget, for example, it's pretty cool to be able to filter out, you know, super expensive GPUs and stuff. So this is a great example. This is one of the results that we got. All right, super cool. Now let's talk about using the minus symbol for excluding search terms from your search, okay? So let's say I'm looking for cloud providers, right? But I want cloud providers for machine learning. However, I want to know what's out there. I don't want to know the basic stuff that everybody knows. So I don't want Azure, I don't want AWS, and I don't want Google Cloud. So by using the minus term here, I'm excluding these answers. I'm excluding these search terms from the answers so that we can see cloud providers related to machine learning, but not the mainstream stuff. And when I run this on my search, you see, let's see an example of something that I get. Boom, I get a list of deep learning cloud service providers. And when we go here, I get, all right, so I did get, okay. And the result that I get from my search is a list that does not involve mentioning these search terms inside the actual content of the site. So let's say, you know, resource management, cloud computing for machine learning from the MIT Press. Let's see some of these results. Central research, so related to cloud computing. And then this is a book. So we get this list of deep learning cloud service by Jeff Hale, which if we go here, Google Cloud, AWS, Azure. Mm. Okay, so let's say, so now let's talk about excluding topics from search with the minus operator. So in Google search, you can use the minus operator to exclude certain search terms from appearing in your search. So for example, if I want to look for a cloud provider, right, and I want for a machine learning project, but I don't want any of the mainstream stuff. So I want to exclude from my search the terms Azure, the terms AWS, and the terms Google Cloud. When I run this, I get an answer that is that it contains the expressions cloud provider and machine learning, but does not contain any of these expressions that I just excluded using the minus operator. So I get a very limited number of results related to the topic of cloud providers and machine learning. In this case, containing these keywords, but without Azure without mentioning Azure, AWS, and Google Cloud. So let's see, we get this link. So Crossfit.io, MLOps, we get run machine learning workload on a low-cost cloud provider. So we get a link to an article about low cost. So we get a link to an article. About low-cost cloud computing and AI and ML. We get a bunch of answers of machine learning as a service. There we go. So this is a perfect example of getting a result of something that is more non-traditional from a search because we excluded some terms, right? So this is a great operation. This is a great operator that we could use to kind of like hone in and filter out some of the stuff that we don't want from our search. Now, finally, another expression and another operator that we like is the related operator. So this one helps you get related websites to a given URL. So in this example, let's put related websites to Kaggle.com. The answer is actually really interesting. So we get our bloggers, Udacity, that makes total sense because they make these amazing courses for also topics related to programming, machine learning, etc. We get the NeurIPS conference, which makes sense because they have the best. It's the biggest conference in machine learning probably in the world. We get Top Coder, which is a website to practice your tech skills, and then something called Splunk. Stack Overflow, Coursera. So all these websites make perfect sense. GitHub.com, which is obviously super related to Kaggle. So the interesting thing about using the related operator is that you can, let's say you're doing some exploration and wanting to find out more websites or blogs about a certain topic, you can go to the websites that you actually know and use the related operator to find other websites that are related to the website that you actually know about that topic. Some other things that we could do is use, for example, if we're looking for a paper, right, and we want the PDF, we could say, let's say I want a paper about transformers, right, paper, and I want the PDF, so I'm saying file type PDF. So now this will guarantee to get me. So now this will guarantee to get me as an answer PDFs as a response. So in this case, perfect. The main paper about transformers and one of the most famous papers about this topic, Attention is All You Need, was the first answer. And as you can see, I got just PDFs as the answer. And you can do that for any kind of extension. You can do that, you can do images, you can do text files, whatever you want. I think for now, I covered most of what I wanted to talk about related to, how to do advanced Google search, and some tips for how to do that with machine learning in mind. And in some upcoming videos, I might, go a little bit more into this and look for templates of search expressions that we can use to do more advanced stuff. But for now, I think that's it. So I hope you guys enjoyed. If you like this video, don't forget to like and subscribe, and see you next time. Cheers.